For context, we start with a 3D model, the one we just created, and finish with 2D flat patterns that have the following characteristics. The edge lengths of adjacent pattern pieces are the same and can be sewn together. Undesired strain and sag is eliminated, and the pattern's surface area is as intended. Notch alignment is perfect across adjacent pattern pieces, and finally, there's an appropriate edge offset or seam allowance when needed. In some cases, in order to satisfy these criteria, a relief cut or a dart may be required. But in this case, we will not need to invoke those techniques. Our first step is to create a mesh from the surface and then weld the vertices of the mesh. These are simple Rhino commands. Create the mesh, and here Rhino gives us what's called a quad mesh. We will change this a little later. Then isolate the mesh. Then weld the vertices, and it should take no more than just a few seconds. Now we're going to optimize our mesh topology for 3D to 2D conversion. And we'll use ExactFlat's adaptive remeshing tool for this. Our mesh elements will be changed to triangular polygons, reduced in number and sized correctly for the amount of curvature on the pattern surface. This mesh will be used as input into ExactFlat's 3D to 2D flattening algorithms, so mesh quality is essential. ExactFlat is a two-stage flattener. The first step is to unsew individual pattern pieces from the 3D model and lay them flat. These initial pattern pieces will be perfect if they are developable surfaces. If not, they will need to be optimized by reducing or eliminating any strain or sag. This boat canvas model has a mix of developable and non-developable surfaces, so we'll just optimize all of the pattern pieces. Before we do, let's use ExactFlat's Find tool to arrange the patterns such that they're laid out adjacent to one another. Click an edge and the Find tool will automatically find the edge on the neighboring piece. You can adjust the gap between edges as you deem appropriate. Just click an edge and the edge on the neighboring pattern piece will be found and placed adjacent to the point at which you clicked. Continue in this way until all pattern pieces are found. You can also move and adjust the placement of individual pieces manually by clicking and dragging the piece. Okay, let's clean this up a little more precisely. First, let's click and drag this one, provide a little more separation between these pieces, and there we go. Now, let's select the entire layout and center it in the viewport. Our next step is to optimize the fit of our pattern pieces by eliminating undesired strain and sag. For this, we use the ExactFlat Optimizer. Here are the steps. We select the ExactFlat spring icon. Then we select the pieces we'd like to optimize. You will then be prompted to select a material type. ExactFlat takes into account the stretchiness of the material in question. You can use one of the pre-populated materials or have a material swatch tested for about $50 or less. Then we select OK, and the optimizer will begin. In the status dialog box, you can see the optimizer analyzing one piece at a time. During the analysis, adjustments are made to the shape of each piece. Pieces with high and compound curvature take longer. Pieces that are more planar are much faster. If you want to know how and why ExactFlat is so accurate, reach out to us and we'll show you why we are so confident that the results are accurate and your patterns will fit. Once the patterns are optimized, all that remains is to add a seam allowance, notches, and create a DXF export file. Both are easily applied. In the case of notches, ExactFlat indexes the vertices on each edge in 3D, and maintains those associations in 2D. Therefore, notches are far more accurate than if applied by hand. Lastly, we create a DXF export file for plotting or cutting. Let's import the file and have a look. And on the file, you can see the pattern shapes, the seam allowance, notches, and the grain line. This concludes our video on how to make better marine canvas faster. To recap our process, it involved 3 easy steps. Step 1 is to capture your geometry. For this, we use the ProLiner by Protum. Step 2, convert your ProLiner data to 3D surfaces. We showed how to do this with Rhino 3D by creating surfaces from the point and curve network generated by the ProLiner. Lastly, for step 3, we showed how to convert 3D surfaces into accurate flat patterns using the ExactFlat 3D to 2D digital pattern making add-in for Rhino. Now this is just a sample of the power of moving to a digital workflow. We have more videos and you can schedule an online demo at your convenience. We'll show you how to become an expert faster than you thought possible.